Hi viewers, in this video we will discuss about what is OSI model, why we need OSI model, layers of OSI model. What is OSI model? OSI stands for Open System Interconnection Model, was developed by ISO International Standard Organization. The International Standard Organization develops and publishes a wide range of standards. It is an international non-governmental organization made up of national standards bodies. OSI is a reference model that tells how applications communicate over a network. A reference model is a conceptual framework for understanding relationships. The OSI model consists of 7 layers that describes how the data is sent and received from these layers. OSI model gives a standard for developing communication software to software developers. So, why we need OSI? To allow communication between all networking devices across the entire planet by standardizing data networking protocols. It provides a common platform for software developers and hardware manufacturers for creating network products that can communicate with each other over the network. It helps network administrators by dividing large data exchange process into smaller segments because it's easy to understand, manage and troubleshoot that are in smaller segments. So next, what is OSI model? OSI model uses layered approach to address all required technologies and devices in effective communication in hierarchical way. So it divides entire communication process in 7 layers. Each layer performs a specific function. The main function of these layers is to communicate with the layers above and below them in the model. It uses bottom-up approach. Now we will see how each layer works. First, physical layer. It is the lowest layer of the OSI model. The data is transferred in the form of bits, which is a string of ones and zeros, through cables and switches. This layer covers a variety of devices and mediums like cabling, connectors, receivers, transceivers, and repeaters. Second, data link layer. Direct connected nodes are used to perform node-to-node data transfer in data link layer. The data in this layer is transmitted in the form of frames. This layer corrects errors that may have occurred at the physical layer. It has 2 sublayers. First is MAC, Media Access Control, that provides flow control and multiplexing for device transmissions over a network. Second is LLC, Logical Link Control, which provides flow and error control over the physical medium and identifies line protocols. Next, network layer. This layer is responsible for receiving frames from the data link layer. Based on the addresses contained inside the frame, it delivers them to desired destinations. The data in this layer is in the form of packets. This layer finds the destination by using logical addresses like IP Internet Protocol. Routers play an important role at this layer to route information that needs to go between networks. The fourth layer is transport layer. In this layer, the data is transferred in the form of segments. Transport layer manages the delivery and error checking of data packets. The main responsibility of this layer is the flow control and error control. The flow control determines optimal speed of transmission by ensuring if sender with a fast connection doesn't destroy a receiver with a slow connection. The error control is done on the receiving end to ensure that data is correctly transmitted or not. The fifth one is a session layer. This layer is responsible for start and end communication between the two devices. The time between this communication is known as session. To avoid wasting resources, this layer closes the session once all the data is transferred. The sixth is presentation layer. This layer is responsible for translation, encryption, and compression of data. When two devices communicates using some encoding methods, then this layer is responsible for translating incoming data into a syntax, so the receiving device at application layer can understand. In another scenario, if two devices are communicating over an encrypted connection, this layer is responsible to add encryption on the sender's end. Next, decode the encryption on receiver's end. So it can present the application layer with unencrypted readable data. The last layer in OSI model is application layer. This layer directly interacts with data from the user. To initiate communication, software applications like web browsers, email clients rely on this layer. But client software applications are not part of the application layer. This layer is responsible for the protocols and data manipulation that the software relies on to present meaningful data to users. The protocols include HTTP, SMTP. So this is how the OSI model works. Thank you. We'll see you in the next video.
For more videos, please download our application Cyber Future Tech from Google Play Store.